Alright, so factoring polynomials part 2. Today is really going to be just some formulas, some general formulas, and then we're just going to have to practice recognizing them. And then finally we'll talk about applying a strategy for factoring polynomials, so we'll have all these kind of tools in our tool bag that we're going to use to try to figure out the best way and how to apply each one. So to start with the difference of squares, you want to think about this as conjugate pairs. So anytime we have two squares subtracted here, so we have a squared minus b squared, a difference of two squares, it essentially becomes the two conjugate pairs where one's minus, one's plus. If we look at our example then, a squared is 81x squared, which means a is 9x, and b squared is 49, which means b is 7. So if we were to factor 81x squared minus 49, we'd just end up with 9x minus 7 and 9x plus 7. Okay, one note, it doesn't really matter which order you put these in. You could have 9x plus 7 times 9x minus 7 in the end. You'd get the same answer either way. Okay, so that's difference of two squares. Biggest thing is just being able to recognize a squared minus b squared. And so we need to know our squares, perfect squares. Okay, difference of two cubes is similar, where we have a difference of two cubes, like in our example here, we've got two perfect cubes are subtracted, and we're going to still have a formula. So two perfect cubes subtracted is going to give us a minus b times a squared plus ab plus b squared. And then you'll be able to stop there because this is going to be unfactorable. Okay. So if we take 64x cubed minus 125, that means this is a cubed and this is b cubed. Hardest thing here usually is identifying what are a and b and what are the perfect cubes. So 64 is 4 cubed, so a is going to be 4x, and 125 is 5 cubed, so b is going to be 5. This then would simplify. We just want to plug in a minus b, so that's going to be 4x minus 5 times, we need to do a squared, and here's the trick. Make sure you square both of these. So we have to take 4 squared and x squared, which is going to give us 16x squared, plus multiplying a times b. Since we have two constants here, we can multiply them. We're going to get 20x plus b squared. Well, 5 squared is going to give us 25. And again, this last piece is unfactorable. You won't even need to check that. It's always going to be the case in this case. So this would be as far as we can go. Okay, the sum of two cubes then is very similar. It's just two cubes that are combined and combined or added. And when we do that, we are going to get a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. So if we look at our example here, x cubed, that tells us that a is just x, and 1, that tells us that b is 1 because 1 cubed is still 1. So plugging in real quick, plugging in a plus b, that's going to be just x plus 1 times a squared in this case. Simplifies a little bit because we don't have a coefficient for x cubed. That's just going to be x squared minus ab is 1x, so I'm just going to write that as x, plus b squared is 1 squared, which just gives us 1. And again, this same idea, this is, we can say non-factorable. So this would be the end. That's it. Okay, so 3 formulas today essentially that we need to become very familiar with and have memorized, and that's going to help us with our strategy for factoring polynomials. So 3 big things here. First thing you want to look for is a greatest common factor. If it's possible, factor out that greatest common factor. Second thing is you're going to ask yourself how many terms are in my polynomial. We have 3 options essentially that will be easily factorable, that we're going to look, or will be easier to factor, that we're going to look at. First one is if we have 2 terms, then you are looking for what we talked about today, difference of 2 squares, and then the sum or difference of 2 cubes. So this is all part 2. So greatest common factor, then we're looking for how many terms, either part 2 or part 1. 3 terms means it's factoring according to trinomials, which one we talked about was ax squared plus bx plus c. Again, this exponent doesn't have to be 2, this doesn't have to be a 1. It could be ax to the 4th plus bx squared plus c. That goes back to the video from part 1. There will be some of those that are unfactorable and non-factorable. Next option then would be 4 terms that we could look at, and that is when we want to start looking at factor by grouping, which again was, I believe, the second thing we looked at on part 1 video. After we've done all those things, if we've factored as much as we can, or we think we factored as much as we can, we need to make sure then that any of the factors we created are not, again, able to be factored again. So an example of one that might look like that is if we talk about 5x cubed minus 45x. And taking our first step, this will have a greatest common factor. The greatest common factor in this case would be 5x, because both of these are divisible by 5, and we can factor out an x from each one. So I'm going to start by factoring out a 5x, which means 5x cubed divided by 5x is going to give us x squared, minus 45 divided by 5 is going to give us 9, and we factored out that x as well, so it leaves it like that. Now we look at this and think, okay, we factored it, we're done. The problem is, inside our parentheses here, we have a difference of squares. And since they are both perfect squares, we can factor that again. So this is where we need to make sure that we're looking for that fourth piece we talked about in the strategy for factoring polynomials, where we look for our extra piece to factor. And this goes back then to a difference of squares, which we talked about today. Since a is x and b is 9, or I'm sorry, b is 3. A is x, b is 3 in our difference of squares. We just think about your conjugate pairs. So x minus 3 and x plus 3. Okay, that's the biggest thing from that, is to write them as conjugate pairs. All right, so that is all for today's lesson. When we meet together next session, we are really going to look at identifying the difference of squares and the sum of difference of cubes, and then hopefully we'll have time to move on from them to actually practice some. But we need to be sure that we can identify them first. All right, we'll see you next session.